Hey, 5th grade mathematicians. Today we're going to do entry task day 117. I'm recording this out in my yard. It's a beautiful day and there's a lot of extra noise, so you'll hear some goats, maybe some turkeys and chickens, maybe some motorcycles, things like that. But that's okay. It's a nice day out. So let's take a look at problem number 1. It says enter the difference 52 minus 16 and 1400. So when we add and subtract, we always have to line up our place value. So we have 52 minus 16 and 1400s. Now you notice 52 does not have the tenths or hundredths recorded, so I'm going to do that. We know that we cannot take 4 from 0 here without borrowing, so I'm going to go over here. I'm going to borrow that 10. We're going to borrow from 10. That'll become 9. There we go. So 10 minus 4 is 6. 9 minus 1 is 8. I cannot take 6 from 1, so I have to borrow again. And 11 minus 6 is 5. So I have 35 and 86 hundredths. Now I want to check my answer by adding back up. So I'm going to add 16 and 14 hundredths, and I should end up with 52. And I do. So there we have it. Our difference is 35 and 86 hundredths. It's always a good thing to do your checking, even though sometimes we get really confident. We're like, oh, I got this. But even the best of us will overlook things at times, so we want to just have some things that we can check our work with. All right, number 2. Zane spends 128 minutes playing math games. He divides his time equally between 10 different games. Enter the number of minutes Zane spent playing each game. So what is our whole? And our whole here is that he has 128 minutes. So in this division problem, they tell us the whole, and they tell us how many parts. There are 10 parts. And each of these parts is a game, and we're supposed to find out how many minutes per game. So we would set up our equation, the whole divided by the number of parts would give us the number of minutes in each part. So we have 12 and 8/10 minutes. And that takes us back, remember when way back at the beginning of the school year when we learned how to divide powers of 10 by shifting digits left or right. When we're dividing, we shift all the digits to the left, one place for each power of 10. So he spends 12.8 minutes per game. Okie dokie. Next problem. Enter the number that makes the equation true. So that equation is what type of an equation? It is an addition equation, but it includes fractions, so we have to have common denominators. So what did they do here? They separated the whole numbers. Whoops. Let me get my pen here. So they separated 2 from 2/4, and 2/4 is equal to 1/2, and we look at our fractions here, and we know that 18 is a half of 36, so that's equivalent. And the whole number there is 4, and the fractional part with 4 is 6/9. So I have to determine 6/9 is how many 36? And the question, I always start with what I am given. I'm given 9 and 36. And I would ask myself, how do I get from 9 to 36? Well, I multiply by 4. And I would also have to multiply this by 4 because 4 fourths is equal to 1. Remember, I'm not changing the value. I'm changing what it looks like, or the form. So I see that 6/9 is 24/36. So I will simply insert 24 in my answer. Okie dokie. Our next problem. A quadrilateral is a two-dimensional figure with 4 sides and 4 angles. Determine if each shape described is also a quadrilateral. Well, if I look at all of these shapes, they are all two-dimensional. The rhombus, does it have 4 sides? Yep, 1, 2, 3, 4. And obviously they're all connected, so they all create angles. So yes, that is a quadrilateral. The pentagon, so if we look at the name pent, we know that pent means 5, but let's just confirm this here. 1, 2, 3, 4, 5. Yes, that's a 5-sided object, so it is not a quadrilateral. Remember, it just takes one thing to not follow a rule for us to be able to eliminate it. And in a parallelogram, parallel tells us that we have parallel sides, but we have 1, 2, 3, 4 sides and 4 angles there. So yes, the rhombus and parallelogram are quadrilaterals. However, the pentagon is not.